All right. So the first thing that we need to remember, just a quick little review on these little things. We need to remember that pi is 180 degrees. And we need to be able to remember that all these other radians here and the degrees that they represent, right? Pi on 6 is 30, pi on 4 is 45, pi on 3 is 60, and so on, right? Next, we need to remember these graphs, right? We'll go a little more in depth in these graphs. But the first graph on top is the sine graph, right? And you need to remember the features about the sine graph, right? Right, sine graph, one cycle is 360 degrees. Maximum value is 1. Smallest value is -1. Sine 90 is 1. Sine 270 is -1. Right? Sine is positive in the first and the second quadrant, and it's negative in the third and the fourth. The cosine graph is a cosine graph here. Largest value is 1. Smallest value is -1. First quadrant positive. Fourth quadrant positive. Second and third quadrants are negative. Tan graph has the asymptotes here, right? Asymptotes means that those values do not exist, right? Tan 90 and tan 270, go to the calculator. Try to find tan 90 and tan 270 and you'll see that those values don't exist. Those are your asymptotes, right? Look at the graph. Anybody could tell me how long it takes for one cycle of a tan graph? 180. One cycle is like this, right? One cycle is like that. What graph does that tan graph look like? X cubed. Okay, so you have your tan graph here. Your tan graph is positive in your first quadrant, your third quadrant negative in your second quadrant, and your fourth quadrant. So those are the things that we need to remember about sine, cos, and tan graph, right? Next thing that we need to remember is this quadrant thing here. First quadrant, everything positive. First quadrant is the values that you'll get in the calculator. Second quadrant is when sine positive. Third quadrant, tan positive. Fourth quadrant, cos positive, right? To get the value in the second quadrant, you minus it from theta. To get the value in the third quadrant, you add it to theta. To get the value in the fourth quadrant, 2 theta minus 2 pi minus theta. All right? We're going into this first, right? So let's quickly try to work this out. Sine theta is a half. Can you find all the solutions between 0 and 2 pi? We are not working in degrees anymore, right? Let's work in radians. Try that for a minute. Right, so theta is equal to sine inverse a half. That will give you the value in the first quadrant, which is pi on 6. When again is sine positive, Shavish, which quadrant? Quadrant 2. How do you get the value in quadrant 2? Pi minus pi on 6. So you're going to get pi on 6. Right, so those are the Form 5 things that you need to remember. Suppose it was sine theta is equal to negative a half. Theta will be sine inverse negative a half. There's a problem with some calculators, right? If you try to find sine inverse negative a half, you are going to get minus pi on 6. But that's not in the range. So to avoid that, what you just do is just come to the side and in a calculator, work out sine inverse a half, and you'll get 30, right? And because sine is negative in the third quadrant and the fourth quadrant, you use this to get your answer. Pi plus pi on 6, 2 pi minus pi on 6. So the problem now is what happens when it goes to 2 theta. I like to show you graphically, right? So let's take a look at graphs. All right, so let's say I gave you the graph of sine theta, right? The graph of sine theta looks something like this. Here is 2 pi, here is pi, here is 1, here is -1. So if I say, can you find the value of sine theta equal to a half between 0 and 2 pi? Right, you'll follow the instructions that I gave you, right? You would find theta, sine inverse a half. That was pi on 6, right? And then the second value would have been 5 pi on 6. So if you had to show that graphically, a half is here, you draw a line. When I say to solve this, what you're really doing is you are finding these two solutions. And your first solution was pi on 6. And your second solution is 5 pi on 6. Right? Pi on 6 and 5 pi on 6. What happens now if I say, well, here's what? Find sine 2 theta equal to a half. Well, what we have to be able to identify is what does the graph for sine 2 theta look like? Well, 2 theta affects something called the period. To find the period of any graph is always 2 pi over b, right? What is b? The general form. The general form of any trig equation is y is equal to a sine bx plus c. So b is the value, this b is the value in front of x. So for example now, if I said b is 2, then the period will now become 2 pi over 2, which is pi. So it means that the period is now smaller. So it takes pi for one cycle. So watch this here now. If it takes pi for one cycle, it means that one cycle will be done after pi. So between pi and 2 pi, you'll have a next cycle. What does that say? That says that for sine 2 theta, between 0 and 2 pi, we have 2 cycles. So now, let's go back to our original problem. What is sine 2 theta equal to a half? Remember, here's 1. So the middle is a half. So you draw a line all the way across. What you recognize it? How much times is that line touching the curve? 4 times. So you have one solution here, a next solution here, and a next solution here. You have 4 solutions now. So if I ask you to solve sine 2 theta is equal to a half, you have 4 solutions. So I want to show you now how to get those 4 solutions. So sine 2 theta is equal to a half between 0 and 2 pi. So you're going to write 2 theta is equal to sine inverse a half. We already have those answers. That was pi on 6 and 5 pi on 6. Now, how do we get the next 2 values? Look back at the graph. Right, my graph is not perfect, but watch this here. How long after this point did this point occur? The third point. A whole cycle. How long after this point here did this point occur? You'll see that? A whole cycle later. So in order for us to get the next 2 values, I have to add on a cycle, 2 pi. So for 2 theta, your answers are pi on 6, 5 pi on 6, 12 on 1, 13 pi on 6. What's going to happen now? Because it's theta, we're going to divide everything by 2. So you're going to get pi on 12, 5 pi on 12, 13 pi on 12, 17 pi on 12. So if you had these 2 values, you're adding pi. But because we don't have those 2 values, you're adding 2 pi. So this is very important. So now you have 4 answers, and those 4 answers within the range. So when you're solving now and you see that the value in front of theta changing, it gives you an idea of how much solutions. Suppose it was sine 3 theta. How many solutions I think it will have? All right, 6 solutions. Of course, between 0 and 2 pi, right? While we're here, let's take a look at the graph side of things, right? Right, so you have an idea when you see a graph, you know what everything means, right? A represents the amplitude, right? B is used to find period. Period is 2 pi on P. C is your vertical shift. right? So anytime you're working with a graph, you need to remember those things, right? So I want to show you now how to sketch a graph quickly. Suppose I said y is equal to 3 sine 2x plus 4. What will that graph look like? All right, so watch this here. Always remember what the sine graph looks like. Sine graph looks something like this. Largest value 1, smallest minus 1. Here 2 pi. So let's see how this graph going and change. Number 1, amplitude. The amplitude of this graph is 3. Right? The period of this graph is 2 pi over 2, which is pi. And the shift positive 4, so it's going 4 upwards. So the graph going to look like that. So how are we going to draw this? This was your 0 line, but we shift the graph where? 4 up. So it will now be, let's pretend here is 4. So that will be a new middle line or a new equilibrium line, right? The graph will start here, come up here, come down here, come up here, and so on, right? The graph will look something like this between 0 and 2 pi because the period is now pi. So if the equilibrium line, right, the 0 line is now 4 and the amplitude is 3, then what's the maximum value? 7, right? So it means you're going up 7 and you're going down to 1. And you're good to go, right? The reason I figured out the maximum value, I took the amplitude and I added to the new equilibrium line, and then I took the amplitude and I minus it from the equilibrium line. Okay, so technically that's how you draw trig graphs. Try this one here, and I'll just do one sketch from it. Y is equal to 5 sine a half x minus 2. Try this, please. Sketch it from between 0 and 2 pi. All right, so let's check this one out here. The amplitude is 5. The period is 2 pi over half, so the period is 4 pi. Remember, I only want up to 2 pi, yeah? And the shift is 2 down. So I will set it up like this. There's a 0 line, right? It went 2 down, so this is a new line where everything will start from, right? The period is 5, so you're going up 5, so minus 2 to what, 3? Right? This amplitude here is 5 plus minus 2, which is 3. And then it going down to like 7. It going down to like minus 7. But we have a big problem, right? A whole cycle takes 4 pi, right? But I didn't ask for 4 pi. I asked for 0 to 2 pi. So therefore, you're only going to show half the cycle. So that's what your answer will look like. So now I just want to mention something. Suppose I said 5 sine a half x minus 2 when it's equal to 0, let's say. Right? The solutions you're looking for, I want you to solve this now. The solutions that you will get will be here and here. You're supposed to only get 2 valid solutions. All right? Do that for me. Solve that between 0 and 2 pi. Let's see if in the end we get our solutions here and here. So you're going to get sine a half x, carry across the 2, carry across the 5. So a half x is equal to sine inverse of 2/5, which is how much? 0.41. Yeah, let's do 0.4. And next value. Watch this here, right? Because it's a half x, remember, it's between 0 and 2 pi for x. So it's between 0 If I divide everything by 2, it's between 0 and pi for half x. So you still have to get one more value, which is pi minus 0.4 is how much? Right, 2.73. Now you're going to multiply everything by 2. So x is equal to 0.8 and 5.46. Right, so those are your two answers here. This answer here is 0.8. This answer here, 5.46. So I'm just trying to show you how graphically and mathematically the solution is supposed to coincide, right? Without using identities, let's see if we could solve the next one, right? Let's see if you remember how to solve those. Look at the range again, please, all, 0 and pi, right? All right, so we have 4 sine squared theta minus 4 sine theta minus 3 is equal to 0. Sorry, plus 4 sine theta. When you solve the quadratic, what you're ending up with? Yeah, it's a half and minus 3 and 2. So we come here and we find sine theta is equal to a half. Theta is equal to sine inverse a half. Theta is equal to pi on 6 and that's 30, right? And 5 pi on 6. Is that within the range? Yeah. The range is 0 to pi. So we got to go. So the next thing we have to look at, we need to be able to use back the identities then. Suppose I said 4 cos squared theta minus 4 sine theta minus 1 is 0. How you will solve something like this? Changing cos squared to what? Nice. And then you will get something like this, right? You'll probably get the same thing. So if you look back here, so these are all that you need to know from Form 5. Form 6 now is where we're going to add on a few more. Before we start trying to work with the identities, I want to introduce 3 new things. I may have told you all already, but sec theta is 1 on cos theta. Cosec theta, cosec is 1 on sine, and cot theta is 1 on tan or cos theta over sine theta. So let's do my favor now. You don't have to write down all of these, just write down those 3 new ones, please. Let's now use these old identities and just practice some proven identities, right? Because you know that was something that we generally didn't like. All right, so let me start here with a nice one, with a past paper one time, right? Sec squared theta is equal to cosec theta all over cosec theta minus sine theta. Remember I told you when you're doing identities, sometimes it's okay to cheat a little bit, right? Take the left side and work it out. Sec squared is 1 on cos squared. So what that means now is we know that the right-hand side, when we simplify cosec theta over cosec theta minus sine theta, when we simplify this, we're supposed to get 1 on cos squared. All right, take your time. The trick is to simplify it properly, right? So cosine is 1 on sine theta. I'm not doing it here. I just write, over the first line. All right, go ahead, have fun. All right, so what we got here? I have 1 on sine theta divided by that thing in the bracket there. What will be underneath? Right, and what will be on top? 1 by 1 is 1. Sine by sine is sine squared. And you put this sine in the middle. So this is 1 on sine theta multiplied by sine theta all over 1 minus sine squared. This will cancel, and 1 minus sine squared is cos squared, which is equal to sec squared. All right, so that was 2016. I'm giving you the next part of the question one time. It's a hence, right? Hence solve cosec theta over cosec theta minus sine theta is 4/3 between 0 and 2 pi. What do we know cosec and cosec minus sine theta to be, Shavish? Right, sec squared theta. Any idea how to solve sec squared theta? Sec squared is 1 over cos squared. And now, what you'll do? Flip it over and work it out, right? Go ahead, have fun. So cosine squared is equal to 3 and 4. So cosine theta is the square root 3 and 4. So that will be cosine theta is plus and minus root 3 and 2. So you're doing it for the positive first. Cosine inverse root 3 and 2. So it's pi on 6. And cos is negative in the fourth quadrant, so that's pi minus pi on 6. So that's 11 pi on 6. That's the first two values, and then cos inverse minus root 3 on 2. That will be pi minus pi on 6, pi plus pi on 6. 5 pi on 6, 7 pi on 6. Okay, so those are your 4 answers, right? All 4 represent a solution. Okay, last thing. Prove cot y minus cot x all over cot x plus cot y is equal to sine x minus y over sine x plus y. Right, so technically today we were able to take a look at the 3 new functions, cosec, cot, and sec. Okay, try this one here. All right, so what does sine x minus y look like? So it will be sine x cos y minus sine y all over sine x cos y plus sine y cos x. Right, so if I take the left hand side, right, the left hand side of cot t minus cot x, right? So cot is cos y over sine y minus cos x over all over cos x cos y plus cos y on sine y. Right. So the problem here is that we need to find a way to make it look like this, right? So the first thing I could probably try to do is try to find the LCM on top. So that'll be sine y sine x, and I will get cos y sine x minus cos x sine y. I'm dividing it by LCM here, right? Sine y sine x again. You'll get cos x sine y cos y sine y. Y again, y and y. Oh, that should have been x, right? Right. When I flip it over now, I'll end up with cos y sine x minus cos y sine y all over sine y sine x multiplied by sine x sine y all over cos x sine y plus cos y sine x. Right? You'll recognize that this will cancel, and then this here is the same as this, and this here is the same as this. So you'll end up with sine x minus y over sine x plus y.